Yes, it was. The Cortana thing? Okay. We have too many like fake people out there. We have Siri, we have Cortana, we have Alexa, we have done. Then there's the Australian guy. Anyway, coming back. Listen to Katrina's Siri, and then you'll be like, oh. Okay, coming back. This page, few things that are special about parametric. Number 1, there's a t. Number 2, x and y are both dependent on t. Number 3, you can graph non-functions in parametric. Number 4, particles can go backwards or forwards. Parametric is showing the motion along a path. So we have to find these little things called orientation arrows. And orientation arrows we can always tell by saying, hey, let's go in increasing orders of t. Time is moving forward, so from negative to positive, time only goes one direction. So if I'm connecting this way, that must have been the orientation. But with a different pair of equations, because parametric come in pairs, the particle could have been on the exact same path going backwards, or because of the timing, it could have been going faster or slower. For instance, you guys look at these two. Which of these pairs of functions, parametric equations, show the faster object? Who's faster? First one, because he's reaching here in only 1.5 seconds, pretend. This guy's reaching it in 3 seconds. So this guy's way down the road when that guy hits that point. You could think of it as a race and a marker. And anyway, this guy hits way before him. Why? Because the time is lower. So depending on time, our functions can look quite differently. But what I was saying was, okay, so even though parametric equations can look different, they can have the same path. So this whole parametric thing, is there a way to ignore the t? Did anybody follow the math at the end of yesterday? Or even some of you guys just looking at it for the first time, follow the math. How did I ignore the t to get back to what I'm familiar with? I got to f of x by solving for t and plugging it into the other one. I have 2 equations. I can solve for t and plug into the other t, and all of a sudden the t is gone. Now it's a function that I can deal with. Rectangular functions. I have a positive square root and a negative square root. Now, once I get to function mode, can I actually know the times anymore? Can I even know the direction of movement if all I know are x's and y's? No. Can I even know the speeds of how fast they're going? No, I can tell nothing. So parametric can tell the when, can tell the how fast, can tell the orientation, like exactly where the particle is moving as in, or regarding like which direction it's headed. Parametric is good, but if I just want to make sure my path is good, I'm going to eliminate, such a good lead-in, eliminate the parameter. Ignore the t, yeah. I need to eliminate the parameter. I need to ignore the t. Eliminate the parameter. Ignore the t. Not spill the tea. Ignore the t. I don't check my email a lot during the day. Eliminate the parameter. What's it mean to eliminate something or someone? Take them out. So who are we taking out? The t. How do we take it out with math? Substitution. How do I substitute? Well, I have to get t by itself first. Wait, kiddos, if you're looking at this and being like, oh, duh, solve for t, plug in. Okay, cool. Oh, duh, solve for t. Why would we be solving the x1 for t? Totally agree. T equals 4x. Well, okay, it doesn't have a squared, but it's a little more important than that. Like, in this one, it is kind of self-serving. Like, it's easier to... It's only one step true, but also, what do rectangular functions usually look like? Y equals Oh, that's for a line. That's for a line. Just any rectangular function. Y equals f of, I want the x's in the equation and the y on the outside. Does that make sense? I want the y alone with the function of x's inside. So I'm going to always solve for the x1 for t. Take it, plug it in. Shoop, shoop, shoop. So y is equal to? Do you know what he looks like? Yeah. I know the path. I know the path. I'm ignoring the timing altogether. But I know the path. And the path is 0, 0, 116, and negative 116. I know the path. Now here's the dilemma. Would that be the graph of the parametric equations? Not necessarily. Meaning, if they were to give me a time interval, which they didn't, but if they were to give me a time interval like t within 0 to 7, would I see the entire path? No, because all I'm asking is, well, what part of the path has it, the particle, whatever you're talking about that's moving or in motion on that path? I'm asking, well, where has it gone? And maybe it's only gone from here to here. Maybe it's gone from here to here. Maybe it's gone from here to here. So it's only going to show you a part of the path that corresponds to the time. But in this one, it did not give you a time interval. It just said, hey, find me the path. Well, did we find the path? Yeah, there it is. It's like, there's the course. There's the entire race. That's the track. We just don't exactly know exactly where this particle that might be moving on this path is at each of these different times because we haven't found it. We haven't looked at it. And we don't even technically know, according to these equations, whether the race is run this direction or that direction. Does that kind of make sense? So we know the path, but not much else. Yeah, go ahead. So ready, set, go. I did an easy one. You guys can do a harder one. Gotta stretch you a little bit. I did an easy one. You do a hard one, but the process is the same. Yeah, it's okay. As long as it's somewhat productive. Ay, ay, ay. Not sure that's productive. P.S. The steps are the exact same. Start with the x equation, x of t, solve for t, plug into the y equation. There is an extra tricky piece, adjusting the domain. What? Hang in there. All right, you guys got it? What's the weird part of this question? Well, of the question, not of the givens. Adjusting the domain, yeah, that's weird, right? Okay, so that's new, that's different, but hold on. Yeah, the functions weren't super pretty either. But if you were to solve, were you guys able to do it okay in the sense of, hey, we can still get x by itself by multiplying, dividing? Does anybody do that? So square root of t plus 1 equals 1 over x. Square both sides. T plus 1 is equal to 1 over x squared, because 1 over x times 1 over x. I could get t is equal to 1 over x squared minus 1. Now what was it my job to do? Yeah. So I have to go to the y and say, okay, so y is equal to 1 over x squared minus 1 all over whether you guys went back to the t plus 1 and just plugged in 1 over x squared, or whether you plugged this guy in and then the minus 1 plus 1 cancel. Either way, you end up here. Which, I mean, okay. Come on, can any of us really tell exactly what's going on with this guy? Plus 1, minus 1, good. Or technically minus 1 plus 1. How do I simplify complex fractions? Sophomores, I heard there were at least a couple complex fractions on that pre-ACT yesterday. Supposedly, according to Jacob Orrell. Anyway, so coming back. Well, it's a good point. Coming back. Period 2, we did talk about how pettiness is not going to be conducive to a good school community this year or next year. So we need to rise above. So we're going to rise above. Coming back. Take it. Just grain of salt. If you don't need it, just it off. If you do need it, be like, and think about it. Okay. Hopefully pray about it, but it depends on your relationship with God. So, coming back. How do you simplify this complex fraction? Yeah, gonna use my trick. I like it. Because what happens on top? 1 happens on top. X squared, cool. 1 minus x squared. What happens on bottom? Oh, look at that. So really this is the same thing as y equals 1 minus x squared. Is that a whole lot easier than it was a second ago? I thought so. But pause. If you look at 1 minus x squared, would you ever think there were any domain problems? Does this guy look like he has domain problems? I didn't think so either. But the previous version, yeah, definitely, right, Colby? The previous version looks like he has issues, and then this previous version, ooh, dilemma. This one, it sure appears like x can't equal 0. You guys see this 0? That would make everything undefined. So that's an issue right here. But even earlier than that, don't we have to come back to the square root and say, wait, t must be greater than or equal to -1? Ooh, it can't equal -1. I can't have a 0 in the denominator. Stink. Well, if t needs to be greater than -1, what does that tell me about the values of x? Domain x, right? I need to look here and say, okay, if t needs to be greater than -1, what do I know about x? Yeah, so first of all, it's impossible for x to be negative. What else is it impossible for x to equal? It can't be 0, because that'll never be 0. This can never make a 0. If it's 1 over 0, that's actually infinite. That's a vertical asymptote. So x can't be 0, x can't be negative, but can x be any positive? Try it. Just give me a positive, a random one. Small, big, whatever. Huh? 5. So 5, can I plug in 5 here, 1/5, and have a t that's greater than -1? Yeah, because 1/5 minus 1 will be -4/5. That's okay. Give me another x. 36. 1 over 36 squared. Great. It's big. -1 is negative something not quite 1. Very, very, very close to 1, but not quite 1. Oh, it's good. How about 1/2? Ooh. 1/2 squared is 1/4. 1 over 1/4 is 4. 4 minus 1 is 3. I'm good, as long as x is positive. So at the end of the day, yeah, this looks great. Yeah, this looks perfect, except from the very beginning, because that t could not be -1, it had to be greater than. I was able to figure out my domain, x has to be greater than 0. I can't just go back to the path and totally ignore the restrictions to begin with. It's insane. Oh my. Not sure it's that cool. All right. Oh, is that the Android? No, you're on a... Oh, you're on that. Okay. No. Tablet and phone calculators are awesome. You can like just tap on like intersections and you can like pinch and zoom, and it's so cool. If only like kids wouldn't cheat if they had something with internet access during a test. Anyway, so think about it. Yeah. All right. Ooh, what about this guy? What's weird? First you have cosine and sine, and second, there's not a t. Now, we could make it a t. We could. It's not a big deal, because in your calculator, aren't we kind of used to having to make certain variables into an x because it's the only button that we have? Or now making it a t because it's the only button that we have. So, all right, fine. We can make it 2 cosine t. Why do you think I and or the book, I think they do it too, would write a theta in the problem? What are they trying to get you to remember? It's an angle. Does that make sense? You're going to have to think about trig. Not cost. That's why there's a cosine of t. But it looks like cost, I know. A little 6th grader would say cost. You're better. All right, so if we just followed the eliminating the parameter process, what would you do first? T in x. All right. So let's take the x and let's solve for t. And the way to solve for t would be x over 2 cosine inverse. So I have to divide by 2 and then cosine inverse both sides to get to the t. Okay. Let me make this much more mathematical. This implies x over 2 inverse of cosine equals t. Divide x by 2, inverse cosine both sides, t is equal to, done. Okay. With this, yeah, how fun does it look to plug that into sine? Oh, very fun. Okay. Have fun. Is there another way? Should be what you're hoping right about now. And usually the answer is no. But this time, the answer's yes. There is a spiffy trick that allows us to not go to inverse trig and normal trig and have to think about how that trig works together. And here's the trick. Cosine and sine are related in a way such that if only we could get them put together in this really spiffy formula, we could actually get rid of them. If only we could get them in this equation, we could get rid of them altogether. Huh. Oh. So couldn't we not get tricked by the trig notation, realize that cosine squared and sine squared just says find cosine and square it, find sine and square it, and don't we have a cosine and a sine that we could get alone? Who does cosine equal? Instead of going to what does t equal or what does theta equal, no, we have this really cool Pythagorean property that says get it like this and I'll just give you a 1 instead. Well, let's solve for cosine then. And if we solve for cosine, what do we get? Not solve for theta, not solve for t, solve for cosine, x over 2. Some of you might be seeing it. This guy, solve for sine. What do you get? Y over 3. Anybody seeing it yet? Then couldn't we plug in to where cosine is x over 2 and sine is y over 3? It's in the chapter 10 sections for a reason. Because isn't this x squared over 4 plus y squared over 9 is equal to, who is that guy? Starts with an E and ends with a lips, you slackers. Hyperbolas are worse, aren't they? Who is this guy? A center of 0, 0, and a minor radius of, go over 2 and go up 3. What's the path? An elliptical one. Elliptical orbits, hidden figures. Go team. Anyway, coming back. Right? No, it did. Otherwise, it would have been so disgusting, and who would have had any clue as to sine of cosine inverse of blah? This, it's just a conic section. It's an ellipse, and I'm done. Colby.
Wait, how would this work in, time? Is it, where we're going?
Well, this is the path. So an orbit. This is the path that it's going on. But if you actually want to know at time, for instance, after it enters orbit, if this was patterning something going into orbit, let's say t equals 0 is when it first enters the orbit. Does that make sense? And so you'd have to plug in the t when t is 1, when t is 2, when t is 3, and then you'd have to see where everything is. No. I mean, it could, but no. We're not going three-dimensional with parametric. That's actually what chapter 11, though, is. In a sense, it's three-dimensional vectors. And so, in a sense, you're now putting forces and you're putting movement in the third dimension. We just, since we're not physics and we're not specifically pre-physics, we're not going there. Because chapter 12 is specifically pre-calculus. So we're skipping the pre-physics and going to pre-calculus. But if you are interested in physics or maybe thinking about it or are in it, you might want to look at chapter 11. It's interesting and possibly helpful. But this one, we weren't supposed to be considering the timing. We weren't supposed to be considering the thetas or the t's. We were supposed to be considering just the path. And do we have the path? And the answer is yeah. Yeah, we do. What if they tell us to find the parametric equations? Oh, is it getting harder as we go? Isn't that usually what happens in a section? Start with easy stuff, table, go to harder stuff. This must be the worst. Going from rectangular to parametric. They must tell you, well, if you're going from rectangular to parametric, you're going from no t to all of a sudden needing a t. They gotta tell you something about t, something about the timing, or else you have no clue. So the only way that you can go from rectangular to parametric is if they give you a timing clue. But check it. Haven't you guys kind of gotten used to solving for one and plugging into the other? If they tell you in letter A that t is equal to x, can't I just plug in t and say y is equal to 1 minus who squared? X is t, so t can be x. Oh, hey, look, parametric equation. Wait, no, parametric equations come in pairs. Exactly. Take this guy to be your other one. What are we going to do all of a sudden if they hide x? Well, solve for x. And say, oh, add the x, subtract the t, x is equal to 1 minus t. Hey, look, I already have my first pair. X is equal to 1 minus t. And all I have to do is go ahead and plug it in, plug it in. I guess we could simplify, which would be what? 1 minus 1 plus 2, minus 2t plus t squared. 1 minus 1 would cancel. Pause, pause, pause. T squared minus 2t. Hey! Maybe the easiest thing was last. Kiddos. Ah, that's too easy. You guys can do it. Homework due attempted tomorrow. We just missed 2 homework helps, but they weren't that hard. I think you guys are good. Bye. See ya, see ya. See ya, see ya. Thank you for not bringing politics into the classroom.